Now, a hexahedron of 30 sides rests on one of its corners on HP such that one of its solid diagonal is perpendicular to VP. Draw the projections of the solid. Since it is a hexahedron is the one, there are six hexagonal surfaces. Six surfaces is a hexahedron, which is nothing but it is a cube. And in other words, it is called as a cube. So 30 sides rests on one of its corners on HP. Since he says it is resting on one of the corners on HP, so obviously you have to take the corner position. That means the end points of the front view must have the corner, that is single point, such that one of its solid diagonal perpendicular to VP. Now first we are going to understand what is a solid diagonal. So a diagonal is the one which is joining between the two opposite corners on the same plane. That means if you join between A and C, then it is a diagonal. If you join between B and D, then it becomes the diagonal. It is on the same plane. Is a solid diagonal is the one wherein joining between the two opposite corners of the two parallel planes, in the sense that ABCD is one plane and PQRS is the another plane. So you are joining between the two opposite corners. That means A dash to R dash is one solid diagonal, C dash to P dash is one more solid diagonal, and then B to S is the one more diagonal, and D to Q is the one more diagonal. So now we are considering any one of the diagonals. So we are considering A dash, R dash. So we have to consider a diagonal in such a manner that it must be parallel to VP. Why we have to consider it should be parallel to VP? Because that solid diagonal in the front view has to get the true length. So then only it can be possible for us to make that solid diagonal parallel. So since he says that one of its solid diagonal has to be perpendicular to VP, so the condition for what is a diagonal, solid diagonal, solid diagonal is nothing but is a line. So we can interpret this as a line perpendicular to VP. If a line has to be perpendicular to VP, then that line has to be parallel to HP first. So that is the condition. A line can be perpendicular to VP then only when that line is parallel to HP. So here we are considering a solid diagonal A dash R dash which is inclined to HP but parallel to VP. A dash R dash is the solid diagonal. In the front view it will be, in the top view it will be AR. AR is the line which is parallel. Since it is parallel, so you are getting the true length here. So first we have to draw a square of 30 side. So by such that it is resting on one of its corners. So first you draw this. How? First, by considering any point, measure an angle of 45 degree with respect to vertical on this side and also on this side. By using the compass, you take a radius of 30 and cut it on this side and also cut it on this side to get the point BQ and DS. Similarly, with B as center, draw an arc of radius 30, and similarly with D as center, cut an arc on this to get this point CR. Once you get this, so you join ABCD and A with a dark line. So you name them ABCD and then in the bracket you mention PQRS because that will going to be invisible in the top view. So that means PQRS is at the base and ABCD is at the top surface. Since it is a hexahedron which is a cube, the height is also considered to be 30 So project all these points to the XY line. So when you look from the front view, PQR is near to the observer. So P dash, Q dash, R dash is visible and S is away from the observer. So S dash will be invisible. So we mark them. Then you take the height of 30 and then draw a perpendicular from P dash and you measure 30 and mark that point, and similarly you complete this rectangle. Once you get this, now here D, project this to till here, then you dark them, name them A dash, B dash, C dash is visible and D dash is away from the observer, it is invisible. A dash to P dash is visible, so you dark them. B dash to Q dash is visible, so you dark them, and C dash to R dash is visible, so you dark them. Now Now in this, since it is resting on one of its corners, now if so, since it is resting on one of its corners, so we are making that P dash has to rest on XY line. So P dash is resting on XY line. So you have to rotate the you have to rotate the front view. You have to rotate the first front view position, first position of the front view, such that the solid diagonal has to become parallel. Why that solid diagonal has to become parallel? Because if the solid diagonal has to be perpendicular to VP, then that diagonal has to be parallel to HP. This is according to the condition of projection of straight line, wherein line is perpendicular to VP and parallel to HP. So in the second position, what we have to do is we have to make this A dash, R dash and AR parallel to both HP and VP. So parallel to VP, it is already there. So we have to make it parallel to HP. How to make that? So here you measure the angle between A dash, R dash and A dash, A dash by using the protractor. You measure the angle first. Then that base, you consider P dash is on XY line, and then by using the protractor, whatever the angle you get from here to here, suppose if you get 30 degrees or 35 degrees here, then from P dash you measure that angle and then draw a line. That's just an example. Whatever the angle you get from here to here, you measure that, and then from P dash you measure that angle and you mark that and you draw a line. Then you measure the distance from P dash to R dash. From P dash you cut an arc to get this point R dash. Then similarly measure the length from P dash to Q dash, and from P dash you cut an arc on this to get this point Q dash S dash. So you got the inclined line. So then to this line you draw a perpendicular by using the protractor. You measure an angle of 90 degrees with respect to P dash, R dash, and then draw a perpendicular line. Similarly, you measure the length from P dash to A dash. From P dash you cut an arc on this to get this point A dash. Then from A dash you measure the distance of A dash to C dash. From A dash you draw an arc. Similarly, from R dash you measure the distance with R dash to C dash by using the compass. From here you cut an arc. You are going to get this point C dash. Then join A dash to C dash with a dark line and C dash to R dash with a dark line. And then measure the distance from A dash to B dash by using the compass. From here you cut an arc. You will get this point B dash, D dash. Name them. And then draw a perpendicular. Join between B dash to Q dash with a dark line. And then you will going to get A dash, R dash will going to be on the parallel line. It is parallel to XY. Now the solid diagonal A dash, R dash is parallel to HP, and also it will going to become parallel to VP. Now once you get this, now we have to draw the top view. So draw a vertical projector from A dash and draw a horizontal projector from A to intersect at this point A. Similarly, draw a vertical projector from B dash, D dash and draw a horizontal projector from B and D to intersect at the point B and D. Similarly, draw a vertical projector from C dash and draw a horizontal projector from C to get this point C. So you get A, B, C, D. Then join A to B, B to C, C to D and D to A first with the thin lines. Similarly, draw a vertical projector from P dash and draw a horizontal projector from P to get this point P. Similarly, draw a vertical projector from Q dash, S dash and draw a horizontal projector from Q and S to intersect at the point Q and S. Similarly, draw a vertical projector from R dash and draw a horizontal projector from R to intersect at this point R. Then join P to Q, Q to R, R to S and S to P with thin continuous line. Then join between A to P, B to Q, C to R and D to S with a thin continuous line. Now we need to write the visibility and invisibility. So all the exterior edges of the boundaries of the solids are visible. So join between A to B, B to Q, Q to R, R to S, D to S and D to A. This will going to form all the exterior edges of the boundaries of the solid. So you dark them. When you look from the top view, ABCD is near to the observer. So join between D to C and C to B, that will going to become visible. Okay. So now From C, since when you look from the top view, C dash R dash is near to the observer, so it becomes visible. So CR will become visible. So you dark them. Now we have left out with the options AP, PQ and PS. So here, since if you join PS or PQ, since BC is visible, so PQ has to be invisible because two visible edges can never cross each other. Similarly, since CD is visible, so PS has to be invisible because two visible edges can never cross each other. And also from the point P, PQ and PS is invisible, therefore AP will going to become invisible. So now this is how we will be able to complete the top view of the second position. Now in third position, you can see that he says a solid diagonal has to be perpendicular. So which is the solid diagonal now? A to R is the solid diagonal which is parallel to HP, and now here also it is parallel to VP. Now we have to make this perpendicular to VP. If you want to make it perpendicular to VP, then you have to rotate such that either A should come here or it can be rotated either clockwise or anti-clockwise. So in this case I am rotating clockwise so that A will come on this side and R will going to come on this side. So draw a vertical line first, measure the distance from A to R by using the compass. You consider any point on that vertical line and mark that point as A and cut an arc on this to get this point R. Then you measure the length from A to C. From A you mark that point. Similarly, you measure the distance from A to P by using the compass. From A you mark that point. So from P you draw a horizontal line. Then you measure the length from P to B and also P to D. Both will going to have the same distances. From P you cut an arc on the left side to get this point B, and from P you cut an arc on the right side. You will going to get D. Similarly, from C you measure from C also you draw a horizontal line. From C you measure the distance from C to Q and also C to S by using the compass. From C you cut an arc on this side to get the point Q. From here to cut an arc on the right side you will going to get S. So since we have transferred all the points from here to here, then join them with finish this view exactly the same as that of the second position top view. Once you complete this, now we have to write the front view of the third position. So how to do that? Draw a vertical projector from A, P, C and R. So A, P, C and R. Draw a horizontal projector from A dash to intersect at this point A dash. Similarly, P, draw a horizontal projector from P dash to get this point P dash. Similarly, draw a horizontal projector from C to intersect at this point C dash, and draw a horizontal projector from R to intersect at this R dash. Similarly, draw a vertical projector from BQ and draw a horizontal projector from B dash to intersect at B dash, and then draw a horizontal projector from Q dash to intersect at this point Q dash. Then similarly, draw a vertical projector from D and S and draw a horizontal projector from D dash to intersect at this point D dash, and similarly draw a horizontal projector from S dash to intersect at this point S dash, and name them. Once you name them, then join. So all the exterior edges of the now you have to join first with continuous thin line. Join between A dash to B dash, B dash to C dash, C dash to D dash, and D dash to A dash. Similarly, P dash to Q dash, Q dash to R dash, R dash to S dash, and S dash to P dash. So then join between A to P, B to Q, C to R, and D to S. Once you do that, all these things has to be done by using the thin continuous line. Now we will going to apply the boundary condition of visibility. All the exterior edges of the boundaries of the solids are visible. So we start from P dash to S dash to D dash, D dash to C dash to B dash to Q dash, and Q dash to P dash. This will going to form the exterior edges of the boundaries of the solid, so which is going to be visible. So you dark them. Once you look from here, that is the front view, PQRS is near to the observer, so P dash, Q dash, R dash, S dash will be visible. So P dash, Q dash, R dash, S dash, and S dash P dash will be visible. So you dark them. So from a point R dash, you can see Q dash R dash and R dash S dash is visible. Therefore, C dash R dash is also visible. So now it come to this point. So here, since A is the extreme point, which is when you look from the front view, A is at the farthermost point from the observer. So A becomes invisible. Once A becomes invisible, so then naturally from that point, which are all the edges which is emanating out of that point will also automatically becomes invisible. So which are the points? AP, AB and AD. So these are the edges. So AP will going to become invisible. So you make the dotted line. Similarly, AD will going to be a dotted line, and also AB, which will going to be a dotted line. So done. So this is how we will be able to finish this. Now when you see this solid diagonal AR is perpendicular to VP, when it is perpendicular to HP, when it is perpendicular to VP, then it will be parallel to HP. That means R dash and dash will going to be at the same distance from the XY line. So since it is perpendicular to VP, so obviously in the front view you must get a point. So you are getting a point such that since R is near to the observer, so R dash is visible and A is away from the observer, so A dash becomes invisible. And hence our problem is right.